So doing that has given us the entire model. So you see that we have the first floor, second, third, and the roof level. One of the things associated with this type of structure analysis is that, for large structures such as this, you have to ensure that there is, correctness in your model and there is consistency in the structural idealization. We are going to check that now. Remember, we have our, structural arrangement. This is second and third floor structural layouts. We have just completed the modeling of the second and third floor structural layout, as we explained, and we said that what is usually done when you build. So this is the second floor structural layout, where we say view, we view selected objects only, and then go to plan view. We built this model by creating these members, as we said, and then we copy the members upwards. We copy this upwards by the distance between this floor and the next floor. If that's the second floor structural layout, this is the second and third floor structural layout. The distance between these two floors can be obtained directly from the architectural drawing. So when we go to the architectural drawing, the second floor is 7.9 meters relative to the finished ground level, and then the third floor is 11.4. So the difference between the two is what you're going to use in developing the structural layout. So if we do 11.4 minus 7.9, that gives us 3.5. So what we did in our modeling, if we display the full structure, this is the second floor structural layout. We just had to copy, like we said before. If you measure distance between here and here, that's 3.5. So we copied the entire second floor. How do you copy? You go to the right view, you select, use the beam cursor, select the entire second floor, right click, copy, right click, and then paste beams. Once you do that, you put in the distance between this and that floor, it will copy and paste it. This is exactly what we did for the second floor, and then for the roof layouts. Then we check the model and then make the corresponding modification associated with that floor. So if I go to the third floor and we look at the third floor, we click on plan view, remove this dimension so it's clear for you. This is how you remove dimension. You would see the third floor structural layouts that we have just developed. We need to now check that everything is correct and you don't have any form of errors. It is very crucial. How do we do that? Let's look at the third floor structural layout first of all. Okay, this is it. Let me take out some information. I'll make it very clear for me to work. Okay, so I can see clearly. Now on the third floor, we have this beam there. We have that beam. This is a 1, 2, 3, 4 span continuous beam. 1, 2, 3. So I have this beam. There's a gap there. I have this other beam here. There's a gap there with the slab, and then I have this other beam here. So it's correct. Then I have this beam here. I have it there. And then I have this one, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's correct. There's a column there. Let's check properly by also viewing the columns that's coming from the preceding floor so that we are sure of what we have just modeled. So I click on this, that will display the entire structure. Then go to front view. I was looking at the third floor, so I will select both the columns and then the third floor beams. View and then view selected objects only. So let me look at what I have done. So you need to make sure everything is very correct. Both the columns that are starting or are continuing from the preceding floor to the next floor, you need to be sure that you have modeled it correctly, and anything that is not correct would have to be deleted. So I'm saying that, okay, this is correct. I have this column here, this column there, then here there's a column, or there are two columns rather. Okay, there's a column here and there's a column there. Okay, these are C1s. C1s are columns that comment from the foundation. And then there's one here just between this void. There's one there, so we are correct. So this floor is largely correct. Let me look at this place quickly. Alright, I have this column, that column, that column, and this. And this column, that column, that. Okay, so we are correct. So the floors are largely correct. So this is the third floor. Let me look at the second floor to be sure that we are also correct in the modeling. View selected objects only, and then come here. Aha, I can see a mistake. Look at this location here. This is the second floor structural layouts. That's the second floor. If you look here, you see you don't have a column here. We have a column starting from the foundation, in between this void. If you look at the architectural first floor layouts and look at the ground floor layouts, superimpose both of them, you see that we don't have a column here and we don't have a column here. This is where we have a column at the midpoint of this beam, of beam 15. At the midpoint of beam 15. So, but if I come here, I'm seeing that I had model. So this is one of the things you need to check when you're building your model, that all your structural entities, the columns, the beams, the panels, are modeled correctly and you don't have any form of errors. If not, it will change the structural stiffness matrices that are going to be developed for each of the structural members, and you'll be getting erroneous results. So I would select this, select that, and then delete it. Okay, let me go to the preceding floor too. So this is the first floor. You can always check the cursor, gives me the coordinates 7.9 meters, and the first floor is at 7.9 meters. So let me check this is the second floor. Let me check the first floor, because it appears that this column also modeled wrongly on the first floor. So we'll check that now. Front view, select the entire first floor and the columns, view selected object only, and like that. So what am I seeing there? Okay, so the column does not exist here, so the first floor is largely correct. But I can see that this beam is broken here into two, which is wrong. I need to merge it as one beam. So what do? You select this beam and select that beam. Geometry, merge selected object, and say yes, merge. It has made it one beam instead of splitting it with a joint to make it two. The same thing here. Geometry, merge, and merge it. The same here and here. Geometry, merge that beam, and merge that one. So these are what you need to do. You need to check your model. It has to be a direct representation of your structural arrangements, so that your analysis will be as precise as possible. So we are almost there. So this is this member. Let's look at this cantilever that projects outwards. It's about 1.76. Let's just reconfirm. 1.76. Okay, that's here. Let's check from here to here. What I'm seeing is 1.462. Let's reconfirm from here to here. 1.463 or 1.462.5. So something appears to be wrong. We need to check where the problem is from. So go back there. So these beams are giving me 1.76. But there's a column here. This column is at 1 meter from column C1. This is C3. C3 is starting from the first floor. So it's at 1 meter. Okay, so this is second floor and third floor structural layouts. But what I'm looking at here is what floor? You need to be careful. Oh, this is the first floor structural layout. So you need to be looking at the first floor structural layout drawing. So let's go to the first floor structural layout. Okay, all right. So you see, these are part of the hazards of analyzing large floors. You need to be certain that what you're looking at is correct and accurate. Okay, let me confirm. From here to here is 1.7625, so it is correct. So this model is very correct. 1.762, that's good. And then here to here, 1.46, so it's not the same. Go to plan view, use 1.4, 1.76. If you go that, this is here is shorter, 1.4, so we are correct. So after you build the model, the next thing we need to do, let's look at the full structure. The next thing to do is to create your member properties. So create and assign material properties to your analytic model. But before you do that, you need to check this analytic model to make sure you don't have errors. So you run some checks. So staad permits you to carry out some internal checks. You can check whether you have overlapping collinear members, if you have erroneously modeled two beams at the same location in space. You can check whether you have disjointed members or orphan nodes that are modeled that are not connected to any member, and so on. So how do you perform these checks? So you go to tools, check multiple structure. You have one. So if you have multiple structures, it will show you structure 1, structure 2, 3, and as the case implies. If your model is in error, it means that you have structures that are not connected monolithically to each other, so you have some errors. But in this case, we have none. We just have one structure, so we are fine. You check overlapping collinear members, like I just mentioned earlier on. You see, we have no overlapping collinear members, so we are fine. You also check zero length member. If you have made a mistake and you intended modeling a member and you did not continue modeling it and you forgot about it, it will be in your environment and be recorded as a zero length member. When we say okay, there are no zeros, so we are fine. So your model is very fine. Next, we proceed to assign properties. So go to geometry, general. So we're going to create our properties here. Go back to structural mode. Let's start from the first floor. This is the first floor structural layouts. Now, what are the member sizes we have? Okay, we have beams. Alright, we have beams 10, 11, 8, 7, and so on. Now, the beams we are going to assign or create member properties as follows. All the beams you can see on the environment are going to be a 230 by 450 beam. They are going to be a 230 by 450 beam. However, the beams that have been ticked due to the cantilevers and the fact that they are carrying columns from the first floor upwards and they are going to be supporting the preceding floors, we are going to make those beams, the beams that have been ticked, we are going to make them 230 by 550. So these beams that have been ticked by using cyan. These beams are beams supporting the columns on the preceding floor. We are going to make them 230 by 550 beams. You can see that this particular one has a long cantilever. The cantilever is about 1.762 meters. So we are going to make these beams that have been ticked, that have cantilevers, and they are suspending the corresponding subsequent floors. These beams that are ticked are going to be 230 by 550. Other beams that are not ticked, we are going to create beam properties of 230 by 450 and assign to them. So the beams are all prismatic, implying that they have a consistent cross-section throughout their entire length. We do not have tapered beams for the purpose of this analysis. They are isotropic, implying that the elastic properties, the elastic modulus of rigidity, and the Poisson's ratio at any point along the profile length is the same in all directions. That's the definition of material isotropy. So the beams are isotropic and homogeneous, in addition to the fact that these beams are all prismatic. So this is the first floor. We'll start by creating the member size on the first floor. Also note that C1, so if you look at this analytic, look at the structural layout, you see that we have C1, C2, and C3. These are the column tags. C1s are columns that are starting from the foundation and going all straight to the roof. We have mentioned this before. C2, by virtue of the way they are created, they are going to, if you allow them to continue to the roof or beyond the floors in which they exist, they will puncture on the slab. If you look at the architectural first floor structural layout, for example, you see that this is where we have the slab for the first floor. So C2 cannot continue, else it will puncture on the slab. So C2s are columns that terminate on the surface of the first floor and then they just stop there. C3s are columns that start from the first floor and they go all straight to the roof. So our columns for the purpose of analysis are going to be 230 by 230 columns, all C1, C2, and C3. So let's create our structural members. Before we do that, let's look at the other floors. This is the first floor structural layout. The second floor structural layout is what you can see on your screen. We are making all the beams on the second floor to be 230 by 450. 230 by 450 are the beams on the second and third floor structural layouts. On the roof, we are going to have our roof beam. So this roof is a slabbed roof, right? If you look at the architectural drawing once again, this is the roof plan. Okay, so you have your roof trusses here. However, if you look at the section B, you would see that you have a roof, you have a slab above the roof, okay, or beneath the roof. So you have a slab at the roof level, okay. So you have a slab at the roof level. So for the essence of this structural analysis, we have made the roof slab to be 100 millimeter thick. So if you look at the structural load assemblage, we have specified that the roof slabs are 100 millimeter thick. Therefore, the roof beams we are going to use for this design purpose for the roof level is going to be 230